Okay, so let's go ahead and write the steps for solving. And when you're solving, you want to get rid of the fractions that you have in these denominators because otherwise it's too complicated. You have to get a common denominator, add these. And so it's just much easier to right away get rid of all those fractions. So you need to find the LCD and you multiply every term by the LCD over 1 because it'll cancel then those fractions. So multiply by LCD over 1 to get rid of the fractions. And then you go ahead and solve your equation, and there's many different ways you might have to solve, so it just depends. Do you have a quadratic you need to factor? Do you just need to solve for x? So it just depends on the equation you have. Then you always need to check your solutions. This is really important. So see here, it doesn't say check, you just need to know to do that. Because remember we said when you have a rational, the denominator cannot equal 0. So you need to check that your solutions do not make your denominator equal to 0. Okay, so let's go ahead and do this. I need to factor this denominator before I solve, and so x squared plus 2x, I can pull out the GCF, which is x. So I'm going to go ahead and do that. So I have x times x plus 2 plus x minus 1 over x, leave a little room here, equals 1. Okay, the next thing you want to do is figure out what the LCD is once you've factored. And looking at these two denominators, this is just 1 over 1, so I don't need to worry about that 1. There's no number except for 1, so let's go to the variable. X and x, largest exponent is just x. And then there's the factor of x plus 2. So that is my LCD. To get rid of these fractions, I'm going to multiply every single term, so all three of these, by x times x plus 2 over 1. It's just like multiplying everything by the same number, keeps an equivalent equation, like this. Okay. And then we're going to cancel, just like when we're multiplying. Oops. So I look at this first term, this x plus 2 cancels with all of this denominator. And now be careful, you're not left with 0, you do have a 1 here, so don't drop that 1. Plus, on this next term, the x cancels, and you're left with x minus 1 times x plus 2 equals, over here, nothing cancels, so you have x times x plus 2. Okay, so we need to solve. So first thing I need to do is FOIL the x minus 1, x plus 2. So that's x squared plus 2x minus x minus 2 equals, over here I have to distribute the x through my parentheses and I get x squared plus 2x. Let's combine some like terms on this left-hand side. I get x squared. 2x minus x is just x. And 1 minus 2 is negative 1. Okay, at first it looks like it might be a quadratic, but when you go to combine like terms, so when you subtract x squared from both sides, they cancel, which is going to actually make this a little bit easier to solve. And I get x minus 1 equals 2x. Let's subtract x from both sides of the equal sign. And I'm going to come over here. The x's cancel here, and I'm left with negative 1 equals 2x minus x is x. So x equals negative 1. So that's our solution. Now before you make sure that's the solution, go back over here, and you don't have to do a bunch of math. What you have to do is just, actually let me take this, check that number you got in both of these denominators, because this doesn't have a variable over here, and see if I plug in negative 1 into this first denominator, would that equal 0? And no. 1 plus negative 2 is not 0, and if I plug in negative 1 here, I get negative 1. Neither of those are 0. So that means that this checks. It won't make the denominator 0, so it won't make the equation undefined. So this is the solution. So you just need to show in some way that you've checked your solutions.